All right, y'all, so we're moving on to 5-1 here. This chapter is on bisectors of triangles. So here we go. We're going to learn two different theorems. One is called the perpendicular bisector theorem, and the other is called the angle bisector theorem. So here we go. All right, so first of all, the perpendicular bisector theorem. So before we even get into the theorem, let's talk about what a perpendicular bisector is. So you have a segment, okay? You have think of a line segment in your head. Okay, and then in comes another line where it is going to be both perpendicular and it is going to bisect that line. Now, bisecting a line segment, okay, means to split it in half. So you're both splitting that line segment in half and it's perpendicular. Okay, we'll see a picture of it later if you can't visualize it right now. All right, but the perpendicular bisector theorem, now it's a lot of words. Some people might like the words, some people might like the picture. Me personally, I go by the picture. All right, but let's go through it anyways. So if a point lies on a perpendicular bisector of a segment, okay, then that point is equidistant from the endpoints of that segment. Okay, again, for me, that's a lot. I like to go look at the picture and take this step by step. So the first part is this. If we have a perpendicular bisector, okay, now look at this segment right here. It's got two endpoints, okay, and this line is my perpendicular bisector because it is perpendicular because of the right angle, and it splits that original line segment in half. So I have this line segment with two endpoints, and then in comes this line splitting it in half and causing a 90-degree angle, which is the perpendicular part. Okay, if that's the case, well, it's saying that that point, if we have a point, okay, so we got to draw our point on this one. If we have a point on that perpendicular bisector, okay, then that point is equidistant from these original endpoints. Okay, so that's saying that then, in other words, right, you have this, right? So that original point is this one, that everything matches up here, right? The only new part is, we created a line segment in here that is the same. Okay, so if I have a perpendicular bisector and a point on that perpendicular bisector, then that point is equidistant from the endpoints. Okay, so therefore these two would be the same. All right, that's the perpendicular bisector theorem. Okay, let's talk about the converse of that perpendicular bisector theorem. So converse, right, we're switching it around just to give you a heads up, right? It says if a point lies on the perpendicular bisector of a segment, then that point is equidistant from the endpoint. So now we're going to say if that point is equidistant from the endpoints, then it has to lie on the perpendicular bisector. Excuse me, goodness. Then it has to lie on the perpendicular bisector. Okay, so here we go. That's what this is here. So the converse of the perpendicular bisector theorem. Okay, so here it is. If a point is equidistant from the endpoints of a segment, then that point is on the perpendicular bisector of that segment. Okay, so again with the pictures. Okay, if I have something like this, if I have a point that is equidistant from the endpoints, so a point being equidistant from the endpoints, okay, then that point is on the perpendicular bisector of that segment. Okay, so if I had a point equidistant here, that's why these two are the same, well, then that point must lie on the perpendicular bisector. Okay, again, the perpendicular bisector of that segment here. Okay, so it's those two properties, and kind of seeing them side by side, you'll end up seeing that, well, essentially you have the same end picture, okay? You have the same end picture. I mean, maybe I put the right angle on a different side, but you've got the exact same thing here and here. It's just depending on what you start off with, okay? Let's look at an example where we're actually using this property, okay? All right, first example, find x. I think you will be surprised at how simple the application is of this particular topic, okay? But find x, okay? So let's say I had an example like this, and it says to find x, okay? Well, I'm looking at this, and I see that I have a point on a perpendicular bisector, okay? I have a point, a perpendicular, right, bisector, okay, of this segment. Well, according to my property, okay, if I have that, okay, so that's like this one, that's like this right here. If I have a perpendicular bisector, Well, then that means that these two are equidistant. Therefore, they're the same. Therefore, x is 8. Okay? Don't overthink it. Okay? Think about that end picture here, right? I want something that looks like this. Well, if I have this piece and this piece, well, then these two are the same. Okay? So x is equal to 8. All right? There's that one. Okay? Not much else to get from that particular one. Okay? On this next example here. Okay? Again, I've got a perpendicular bisector. Therefore, that point is equidistant from here. What does that mean about these two segments? Well, that means they're the same. Okay? That means that these two are the same. So if I wanted to find x here, well, this time I'm going to have to do some algebra. So I'm going to go ahead and set 6x minus 14 equal to 4x. Okay? Now, keep in mind, right, this would have to be like find x. Okay? Find x here. So 6x minus 14 is equal to 4x. Well, we're going to do some algebra to solve, so I'm going to add 14 on both sides. Okay, and I end up with 6x is equal to 4x plus 14. But I also need to subtract this 4x, so minus 4x minus 4x. So I end up with 2x is equal to 14. And last step, dividing by 2. Therefore, x, let's go ahead and write it, divide by 2. Therefore, x is 7. Okay, now what if the problem asks for this entire length? Okay, well, maybe we would have to have it. Maybe it's let's go ahead and do that. So maybe this is A, B, and C. Okay, what if it asked for AB? What is line segment AB? Well, what do we know about x? We know x is 7. Okay, and if it asks for the length of AB, we do 4 times 7. Okay, so 4 times 7 gives me 28. All right, and let's just double check. It better be 28 over here. Okay, it better be. Just to, double check us. Right, 6 times 7 minus 14. Okay, well, what is 6 times 7? 6 times 7 is 42. 42 minus 14. Does that equal 28? Yeah, it does. Okay, so those are the types of problems you'll see. If you have that it's a perpendicular bisector, you know that these two lengths are the same. Okay, there's that one. All right, on to the next property. Okay, on to the next property. I got so many note cards here. Here we go. Okay, on to the next one. So this is the angle bisector theorem. Okay, if a point, let's get my little note card. Okay, if a point lies on the angle bisector of an angle. Now let's picture an angle bisector before we go any further. Okay, I have an angle. Okay, and then in comes a line that splits that angle in half. That's what an angle bisector is. It's another line splitting an angle in half. That's it. Okay, remember bisecting means to split in half, so I'm splitting that angle in half. But this time I'm splitting the angle. Okay, not the segment. All right, anyways, if a point lies on an angle bisector of an angle, then that point is equidistant from the sides of that angle. Okay, so this time, again, with the pictures. Okay, if I have something that looks like this. Okay, so let's talk about this. Well, here's my angle. Here's my big angle. Okay, that is my original angle. And in comes this line splitting it in half. How do I know it's split in half based on this picture? Well, remember, I've got these rings. Those rings mean that this angle, just this one, is the same as this one. Okay, so it could be like 28 here or something, and then 28 here. I don't know. Okay, so I now know that these two are the same because of that angle bisector. All right, then that means that if I had a point on that line, right? So in both we've got the point. Okay, the point here. Then that point, okay, is equidistant from the sides. Okay, this time from the sides. Okay, so here's a point, equidistant. This right angle is necessary. Okay, I'm going to go ahead and say that. In order to get the distance from a point to a line, you've got to have that right angle distance. So this distance and this distance are the same. Since there's a right angle here and right angle here, and these two lengths are the same, I'm good to go. That is showing me that it's equidistant. Okay. Similarly, we're going to have the converse, and the converse is back here. The converse, okay? Again, flipped around this time. All right, if a point lies in between an angle and is equidistant from the sides, then that point is on the angle bisector of that angle. Okay, so this time I've got, if I have this, right here, here's my point, okay, and if that point, if it lies between an angle, which it does, here's my angle, okay, that point lies between an angle, and it's equidistant from the sides, so equidistant, equidistant, good to go. Okay, then that point is on the angle bisector. Well, that means that if I draw a line, then that point is on that angle bisector. Okay, so here it is. Then I would have, there's my angle bisector, and therefore these two are the same. Okay, so again, if we compare them, okay, if we compare them side to side, we end up with the same picture at the end. Okay, again, we end up with the same picture at the end on this. You see that we've got all those pieces there. It's just what it's starting with. Okay, what it's starting with. So here they are in totality. Okay. All right. Now the two examples again, kind of just like we did. So here we go. Okay. Again, find x. Okay. Well, let's look at what we have. Okay. I have a point. Okay, and that point happens to be equidistant to the sides. Right. I have this big old angle. That point equidistant from the sides. So therefore this and this are the same. And since that is the case, well then that point has to lie on the angle bisector. There's my angle bisector. And if this is going to be an angle bisector, then what do I know about x and 20? That they're the same. Okay, so x is actually equal to 20 degrees, and that is that problem. Okay, but it's again because I know that this line right here is the angle bisector. And the reason I know that it's the angle bisector is because this point is equidistant from the sides of that angle. Okay? And last question. Okay, last example. Here we go. So, okay, let's look at this picture. Again, find x. I should be writing that. Okay, supposed to find x here. All right, so let's look at what we have. Well, I have this time, okay, I've got these two right here. So, I've got this big old angle, and what do I know this line is? Well, that line happens to be the angle bisector because these two are the same. These two angles are the same. So that line is my angle bisector. Well, since that is a point on this angle bisector, then that means I know this and this are the same. Therefore, I know 10x equals 9x plus 1. Okay? And then, therefore, I've got minus 9x, minus 9x. I've got x is equal to 1. And that is my question. Okay? I have answered my question now. Okay? Or that's my answer. That was weird. Why did I say question? Okay? That's my answer. I know that x is equal to 1 there. Again, we can plug it back in just to double check. Maybe we'll do this in our heads. We won't write it down. But 10 times 1, that gives me 10. Okay? 9 times 1 gets me 9 plus 1. So this is also 10. So 10 and 10. And that better be the case if this is an angle bisector. And we know that it is because of these two angles here. And therefore, that point is equidistant to the sides of those angles. Okay? So again, the main two pictures we want to know here are these two. Okay, and maybe it's good to compare them side by side. Okay, but it's these. Okay, let me pull these up. Okay, is everything down here? All right, so this is my perpendicular bisector theorem, and then this is my angle bisector theorem. Okay, so it's those two properties. And you can look at all the different pieces that you have in them, and you can apply some algebra, right? Or you can just apply some basic number, equivalences. Okay? That is 5-1. All right? You guys have a great day. I will see you later.